This is the lecture on digital platforms for hinterland container logistics systems. My name is Rob Zuidwijk. So let's discuss the following questions while covering this topic. So what are digital platforms in this context of container logistics? How do information services on digital platforms support sustainable transportation and logistics? And how can we actually have those information services support emission measurement, reporting, and reduction? The first observation is we all know about digital platforms in daily life. Think about Uber, Airbnb, Booking.com, and many other examples that we almost use on a daily basis, perhaps. Where different users are brought together to perform interactions. We also have this in logistics. Okay, so here we do see on this slide, do see a couple of examples. I'll go a bit more in detail about those different types of services that they provide. They usually will provide, for example, the matching between supply and demand for transportation services. These are a bit different from the examples I started off with, because these are business to consumer examples. In logistics, we almost always talk about business to business solutions, which put different requirements on those digital platforms. One of the oldest digital platforms, if you want, are port community systems. They already exist for decades. They weren't called digital platforms for obvious reasons, but they were systems that would connect several companies that work together to, for example, import containers to the continent. And for that, they need to share information. And in fact, these platforms are information sharing platforms. To connect a bit more explicitly with some more recent developments, which exist for not more than one, perhaps 2 decades if you want, are mobile phones, especially smartphones, in the following way. You can compare those different port community systems with smartphone systems in the following by asking yourself the question: how is the deployment of applications organized for those platforms? And there, for mobile phones, you can think about the philosophy behind Android and the philosophy behind iPhone or iTunes. With the iPhone, with Apple, you see a high level of control by the platform, by the phone, on which apps can be used on the platform and which cannot be used on the platform. In contrast, in the Android philosophy, it's more open, and actually everybody can devise applications for the system. And it's up to reputation systems to make sure that people know which apps are useful and which ones are not useful. In the business-to-business context of port community systems, we see a similar thing. A port authority that is usually responsible, not always, but is usually responsible for the deployment of the port community system, may need to decide on the governance, on the information services that are provided through the platform. Okay, so here a similar question: are you in full control? Is everything that goes onto the platform as an information system, is that indeed fully checked and controlled by the owner of the platform? Or do you allow the market to do its work and where the best apps will be used by the users of the platform? That's about the governance of the information services. Let's now go to some examples to go a bit more into the content of what those information systems actually do. Here an example where we are thinking about the matching of import and export containers. What you see here on the slide, on the top picture, is indeed a typical question of: I have an import container, I have an export cargo offer. The import container will be brought to a place where it will be unloaded. So it's a delivery point where the container will be unloaded. We then have an empty container together with the truck. And then the truck with the empty container will go to an origin, a point where the cargo will be put inside the empty container, which will then be exported to some destination in the world. Now, we need this import and export of this full container, but in between we have this empty container moving from the delivery point and the pickup point of cargo, and that this empty distance needs to be as short as possible. You can compute this, but the point here is that we would like to know what happens if we have more orders to match. Well, you can typically think if you have 10 import orders and 10 export orders, you will have not so much choices to make nice matches in order to have this little distance between the point of delivery and point of origin. But if you have 100 import orders and 100 export orders, you can make much more matches that are more attractive. So if truck operators have import and export orders, they could do a good job in joining forces, bringing all their import and export orders together, and then find the best matches. This will, however, require them to trust each other in the sense that they will allow their container to be brought by the driver of another truck company to their customer. And the question here really is, and this is again a governance question, if you have a platform where you match and indeed save energy and reduce emissions by these smaller empty distances, and you have this network of organizations as depicted on the right-hand side, where the size of the organization is defined by the number of import and export orders that they can bring to the table that can be joined together. And another aspect of this network is at the right-hand side. There will be a link between two organizations when they're actually willing to work together and make a match together. Then the question is, what is that platform actually providing as a benefit? And you can imagine the bigger those organizations are, the more import and export containers there are, the more benefit there will be. The more links there are between organizations, the more possible matches there are, the more benefits there will be. And the question is to see what are the best trade-offs here. So, for example, if the platform the network would like to expand, and we have two candidates as next option, one very big truck operator which does not want to make too many connections with others, and a small operator with a lot of willingness to connect with everybody, then the question is what is best for the platform. And this is something that you could think about. Another problem where we see platforms emerging is in the barge rotation in the port. And actually, we see that barges will visit multiple terminals in the port area. And in fact, we might see a cascade of delays. When there's a delay at the first terminal, it might indeed happen that when it gets delayed there, it will need to visit the second terminal to bring yet other containers to that terminal. And then there might be a cascading because it has to wait because it missed its time slot. There are multiple options available to address the issue. You can think about an hub and spoke system where you try to make sure that the barges will indeed consolidate their freight to go to only one terminal in the port area, so they don't need to make this round trip. You can have an inland corridor where the consolidation then takes place in the hinterland, so one barge will pass through a number of inland terminals, consolidate the freight, and again only visit one deep sea terminal. And we can think about a principle where we actually decide to decouple the traveling by the barge to the different terminals and the actual handling of the containers at the various terminals. Another system could be that you say, well, we still have this rotation of of barges through the port, but now we come up with a more advanced planning system. So if the container is delayed, then actually the barge is delayed, then actually we can do a replan so that the container terminal is not waiting for the barge, or the barge is not too much waiting for the container terminal, because they replan the whole system. For the latter option, indeed, an inter-organizational system, an information system that connects with multiple organizations, has been devised, involving both the barge operators and the container terminals, and this is going for the last solution. But this solution can also be complemented by some of the other solutions that I mentioned, where you try to avoid multiple visits by barges to the seaport. And this again saves a lot of energy, but it involves the use of a platform to coordinate, let's say, planning, but in the first place also to collect data to see where the problems really arise. Platforms can be used to orchestrate logistics. We've seen matching between import and export orders. We have seen coordination of activity in the port area for barges and terminals. But they can also be used, also this logistics data that you collect can also be used to report, to collect data about emissions and to report about it in a standardized fashion. So, for example, a framework used for logistic emission accounting is actually providing the scope for collecting data, and that can actually be done via a digital platform. And information services are then indeed available to say, well, given the data that we have collected, then there are several ways how we can estimate the emissions that actually have occurred during the transport or logistics operations. There are different protocols and methods to do that. And the point of the matter is that digital platforms that collect data also to optimize logistics systems can also be used to report about those emissions. So digital platforms in various ways contribute to saving energy and saving emissions in those logistics systems. So indeed, we may conclude that digital platforms have multiple roles to play in container logistics systems. They facilitate information exchange, they facilitate collaborative planning, they facilitate also other transactions, adding value services like reporting of emissions. Those information services on digital platforms support sustainable transportation by matching indeed supply and demand and those other and coordinating action in supply in transport chains. And these information services in particular can be used for emission reporting when they follow certain standards. Thank you very much for your attention.